In these two examples, we are going to be looking to determine the equations for these visuals. So they both kind of have this tangent look to them. So just a quick refresher. Here's what all the tangent graphs look like that, and everything kind of builds from there is we have an asymptote to an asymptote, and the period here is a pi. And then from here, so this is going to go from pi over 2, negative pi over 2 to positive pi over 2 because of the period. So half of it's on the left, half of it's on the right, which puts these at pi over 4s. And at pi over 4, you should be at a height of 1. At negative pi over 4, you should be at a height of negative 1. And then at 0, we're at 0. So that's our basic tangent graph. And we are looking to create this equation that potentially has a vertical stretch. In sines and cosines, we call them an amplitude, but an amplitude technically is when you're kind of going from the top point to the midline or the bottom point to the midline. I'll still kind of refer to that just because it has a similar feel to it. We have a period adjustment potential, a phase shift, and a midline, right? All these little pieces could come into play. So if I'm looking at this one, it definitely has almost the exact same feel as this. So I don't have any left or right, left, right, or up and down shifts, right? Do I have a vertical stretch? Yes, because normally that point is at a height of 1 or a negative 1, right? And instead we're at a negative 3 and a positive 3. So far we have a 3 tangent. And then my last thing is our period being adjusted. Nope, because if you go from here to here, you're going from a negative pi over 2 to a positive pi over 2. So that period is not being messed with. So that is our equation. All right, so let's see what's going on this one. So if I start to kind of go through all my stuff, this got shifted to the right pi and up 1. So that means I got shifted to the right pi and up 1. So I may have a period adjustment. We'll leave a little space for that. And if we're going to shift right pi, that means we're going to be subtracting pi. And we got shifted up 1. Okay, so we've taken care of those. Let's see if we can figure out our period. So from here to here is 2 pi, but our normal period is pi. So the formula for that is our period is going to be pi divided by a b value. So ours is 2 pi equals pi divided by b. So I got to figure out what that is. And if I can't mentally do it, then I can cross multiply this, or I can multiply the b over. So 2 pi times a b would equal the pi. Divide by 2 pi. And then the pi's would cancel, and I would just have a 1/2 left over. So I have a 1/2 floating here. And then from here, is there a vertical stretch? So normally when I go out, whatever my distance is, because that's affected by your period, I go up 1. But this time, let's see, we are going out and up 1, and then out and then down 1, which perfectly matches our normal pattern. So we don't have any kind of a stretch to it. So let me squeeze the y equals in there because we don't have any vertical stretch or amplitude that's making our graph any steeper than it normally is. All right, and that was finding equations from some graphs. Also, by the way, this could have been a cotangent graph. If you remember what a cotangent graph looks like, it has something that doesn't center around the origin. There's an asymptote at the origin. So if this was a cotangent, normally a cotangent goes down, we'd still have the same midline or up 1. We'd still have the exact same period, except we would have cotangent that's being reflected to go up versus down. and then we would take away the phase shift on them. So there is another possibility, but we were looking to do tangents on these two.